All right, welcome back, ladies and gentlemen. Today we're going to be talking about combine and solve. Now, the goal of our lesson is to learn how to combine like terms and solve equations that deal with combining like terms. Now, before we jump into the examples, let's look at a few definitions. Now, I'm not going word for word with the definitions, but I'm going to tell you what they mean, and we're going to go from there. The first definition is a term. A term is basically a number and a variable that are separated by plus and minus signs. Okay, the variable is a letter that we use to represent unknowns. So if we don't know what we're trying to solve for or what the number is that trying to get, we put a variable there until we're able to find out what that number is. Now, when we have variables, sometimes we have them where they're by themselves and they have a number in front. And if they have a number in front of it, what that's called is your coefficient. Okay, that is always going to be the number in front of a variable. Now we're going to have some numbers that are by themselves, and if we have numbers that are by themselves, those are called constants. Those are the ones that do not change. Okay, and that brings us to the next definition, which is a like term. A like term is a term that has the same variable raised to the same power, and this is our whole goal. Okay, combining like terms. Now to combine a like term, we already know that it has to have the same variable, which is key. Okay, so to combine a like term is actually a process of adding and subtracting. But we can only add and subtract terms that are the same. Okay? And what I mean by add and subtract, you cannot add and subtract the variable. What we're going to be adding or subtracting is the actual coefficient. And that's the number in front of the variable. Okay? So we have to know the difference between the variable and the coefficient. And the coefficient is a number that is always in front of the variable. Okay? When we add and subtract those, we'll keep the variable the same and add and subtract the number in the front. Now we have to be very careful when it comes to combining like terms because if the variables are not the same, we cannot combine those. Okay, so for it to be a like term, it has to have the same variable raised to the same power. Okay, so let's look at it at first example. The first example tells us that we got 10x plus 36 minus 38x minus 47. So we're looking to combine like terms. This is an expression. Okay, so if we're going to combine this expression, we're going to be looking for things that are similar to combine, that are the same to combine together. So like 10x, what we look for is something else that has an x attached to it, which is this negative 38. Okay, so we're going to come to the side of the sheet of paper. We're going to bring down 10x. And I'm going to put the larger number at the top because it's easier to add or subtract that way. So I'm going to put negative 38 at above that with my x. So if I got negative 38 and a positive 10, those signs are different. So because my signs are different, I'm going to subtract the number and keep the sign of the larger. So that's going to give me a negative 28x. Then I go back to my expression to see if I have anything else that I can combine. So I got a positive 36 and a negative 47. All right. The reason why those are like terms is because they don't have a variable. Okay. So I can combine those together. Putting my larger number at the front, I'm gonna put negative 47. Go back to the side of my sheet of paper, and then I'm gonna bring down my positive 36. Now signs are different again in this case because signs are different. I'm gonna subtract. Keep the sign of the larger. That's gonna be 7 minus 6, which is 1. 4 minus 3, which is 1, and that's gonna give me a negative 11. Now when I write this expression, I'm gonna put the variable first and with the coefficient and then the constant next. So my answer will be negative 28x minus 11. All right, so let's look at example 2. Example 2, same thing. I look for things that are common. Okay, first term I have is 30. Do I have anything in common with 30? I'm looking for something that doesn't have a variable behind it, which I do, which is a positive 28. Okay, so I'm going to go to the side of the sheet of paper, put my 30, not 38, put my 30, okay, and then my positive 27 under it. Those are both positive numbers. So because they're both positive numbers, I can add them together and keep the plus sign. So that's going to give me 57. Then I look and go back to my expression on my equation and I see if I have anything else that I can combine. I have a positive 80k, but then I got a negative 9k. They both have k, so I can combine those together. So I'm going to take and put my larger number first, which is positive 80k, above my negative 9. Signs are different, so I subtract. When I subtract 80 and 9, I get 71. And I take the sign of the larger, keeping my variable. Now let's write my expression. I get 71k plus 57. Okay, so that's the solution for that one. Let's look at the next example. In my next example, what we have is negative 7 plus 70x squared plus 8 plus 6x squared. Now with this, same thing. I look for what's in common. I got a negative 7. That doesn't have a variable behind it. So I'm looking for something else that doesn't have a variable, which is that positive 8. So I can combine those. Put my 8 minus my 7. Signs are different, so I subtract. That's going to give me 1. And it's a positive 1 because 8 is larger. Okay, then I look to see if I have anything else in common. Like that positive 70x squared. That has an x squared. So I'm looking for something else that has an x squared, which is just positive 6 in the back. So I can combine those. So that's going to give me a positive 70x squared plus a 6x squared. Same signs combined. That's going to give me 76x squared. Okay, and that's positive. So I'm going to write my expression as 76x squared. Put my variable first with my coefficient. My constant goes behind it, positive 1. So that's how we combine like terms using expressions. Now, we combine those terms. Terms have to have the same variable raised to the same exponent. And even if the ones that don't have a variable behind it, which are your constants, the constants can be combined together as well. Okay, that's something similar. Now that we looked at how to combine, let's look at how we can use combine and then solve. Okay, so in order to solve an equation with combining like terms, the first thing we have to do is locate the variable. All right, so you have to know what you're trying to solve for. All right, once you know what you're solving for, the next thing you're going to do is see if you can combine like terms. If you can combine like terms, you're good. But now if you notice that where it says if necessary, if it's necessary, we'll combine. Sometimes you'll have like terms, sometimes you won't. So that means you'll move to the next step if you do or you don't after it's completed. The next thing we do is use inverse operations. Inverse operations mean you're going to do the opposite operation of what's up there in the problem. So the first thing you look for is addition and subtraction. You're going to undo that. And then after you undo your addition and subtraction, then you're going to be undoing your multiplication and division. Now, once that's taken care of, you should be at the point where you have your variable and you should be good to go from there. Okay? So now let's look at some examples. The first one we're going to look at is the 4x plus 10 equals 34. So I have an equation. What makes this as an equation is that it has an equal sign. The other ones before didn't have an equal sign, so it wasn't an equation. Equations have equal signs. So because this do have an equal sign, what I'm going to do is I'm going to split it down the middle, giving me two sides, the front and the back part. So I check my front part to see if I have anything that I can consider to be a like term. I got a 4x and a positive 10. They're different because one has a variable, one does not. So I can't combine them. Then I look at the back side. It's only a 34. So it's nothing for me to combine there. So that means now I'm going to start using my inverse operations. And I'm going to start with addition or subtraction. I notice I got a positive 10. For me to do the inverse of a positive 10, I got to subtract 10. So what I do to one side, I do to the other. So I'm going to subtract 10 on both sides. Plus 10, negative 10 cancels each other out, bringing down my 4x. And then what we have is 34 minus 10. That's going to give me 24. Signs are opposite, so you'll subtract and take the sign of the larger. Then from there, we're looking at 4x and 24. Whenever you have a number right beside a variable, that means multiply. So for me to undo multiplication, I have to divide. So I'm going to take and divide by 4 on both sides. So I'm going to take that 24 and I'm going to divide it by 4. And what you get is 6. Got 4 divided by 4. 4's cancel each other out, leaving me with just x. So the answer is x is going to be 6. Okay, let's move to the next one. In this next problem, we got x divided by 7 plus 19 equals 24. Same thing. We got an equal sign equation. When I see my equation, I take a line, drop down my equal sign, extending out my equal sign. Next thing I do, can I combine anything? We got x being divided by 7 plus 19 in the front. There's nothing in common to that. Look at the back. It's only 24. There's nothing in common with that being at the back by itself. So we go to inverse operations. We got a positive 19. Opposite is a negative 19. So I put that under it. If I do it on that side, definitely got to do it on the other. You got to keep it balanced. All right, the positive 19 minus the 19 cancel each other out, bringing me x over 7 down. Okay? Now we got 24 minus 19. When you subtract that, you get 5. Positive and the negative, opposite sign, subtract, keep the sign the larger, so we got a 5. Now, if we look at the x over 7, the x over 7 actually means divides. X being divided by 7. The opposite of divide is multiply. So I'm going to take and multiply both sides of my equation by the denominator, which is 7. Okay, 7 times 5 is 35. So I can bring down my 35. And then we got 7 times x over 7. My 7's actually go away, leaving me with just x. So the value of x is 35. Okay, moving on to my next example. We got 6 equals negative 12 minus 9 over 11x. So with this problem, got my equal sign, draw my line. Now I'm looking to see if I have anything that's considered to be a like term. In this case, I don't. Okay, so I go to my inverse operations. With my inverse operations, I'm looking for my constant to either be added or subtracted first. So in this one, because it's out of order from what we did before, my constant is the 12 because it doesn't have a variable behind it. So that means I got to move it to the other side by doing this inverse. So I'm going to add 12. What I do to one side, I do to the other. Alright, so when I do that, negative 12, positive 12 is 0, so it goes away. 6 plus 12 makes 18. Bring 18 down. Didn't use the negative 9 over 11x, so it comes down. Now, there's two ways we can solve this. And we have one that's a little bit longer, but it's easier, and the other one is using the inverse. So I'm going to take you the easier route. And when the easier route says we got to get rid of the denominator first, okay, and then we'll get rid of the numerator. So what I mean by that is this. Denominator is 11. That's dividing. That means I got to multiply to get rid of it. So I'm going to take and multiply by 11 on both sides. When I do that, 11 being multiplied to that 18, it's going to give me 198. But 11 being multiplied to 9 over 11 cancels this 11 out and that one, leaving me with negative 9x. Then the last part says I got to get x by itself. Negative 9 beside x means multiply, opposite means divide, so I'm going to divide both sides by negative 9. When I take that 198 and divide it by negative 9, what we get is negative 22. And that negative 9 divided by negative 9 cancels out, leaving me with just x. So the value of x is negative 22. All right, let's move to the next one. All right, so looking at this one, first thing first, we look for like terms. When we look for like terms, we combine. But I also see my equal sign. So therefore, I'm going to go ahead and draw my line. Okay? Looking at the front side, do I have anything that's considered to be a like term? Well, I got 15x, and I got another x over there with the 4. So if they are separate terms, I can combine those. So let's combine 15 and negative 4. So I'm going to go to my side of my paper. I'm going to take care of that. I'm going to do my 15x. Negative 4, signs are different, so I subtract. That's going to give me 11x. So I can bring down 11x. I didn't use the negative 24, so I'll bring it down. Didn't do anything with the negative 79 either. Okay. Now from there, I don't have anything else I can combine in the front or the back of my equation. So now I'm doing my inverse. So I got to get rid of my constant first. That's by my variable. And that's that negative 24. So I'm going to add 24. Negative 24, positive 24 cancels each other out, bringing down my 11x. Okay, now we got negative 79, positive 24. Signs are opposites. Opposite means we subtract and keep the sign of the larger. 9 minus 4 is 5. 7 minus 2 is 5. Larger is negative, so it's a negative 55. Now we got 11 right beside that x. That means multiply. So the opposite of multiply means I got to divide. So I'm going to divide by 11. Double 11s cancel each other out, leaving me with x. Negative 55 divided by 11 is going to give me negative 5. So x is negative 5. We got one more example. Okay, last example. First thing I notice is my equal sign. So I'm going to divide it, put my line. Look at the front side of my equation, 102 by itself, nothing to combine with. Back side of my equation, what I should notice is I got a negative 7x and a positive 3x. So those are like terms. I can combine them. So if I take and combine them, I'm going to go to the side of my sheet of paper. I got negative 7x, positive 3x. Signs are separate, so I'm going to subtract. That's going to give me 4x, and that's going to be negative because 7 is larger. So I can bring down first what I didn't use, which is 102 and my 69. And behind that, we're going to have negative 4x. Okay, with that being there, I look to see if I have my constant on the side with my variable. I do, 69. It's a positive, so the opposite is subtract. So I got to subtract 69 from both sides. The double 69s, automatically you should know they're going to go away. So I mark them out. And then we take 102 and subtract 69 from it, and we get 33. Okay, now with that, I didn't use my negative 4x. So if I didn't use my negative 4x, I should bring it down. So I'm going to bring down negative 4x. Next thing I'm going to take is divide by negative 4. Got to get x by itself. Okay. Now, negative 4 divided by negative 4, it goes away. Alright, leaving me with just x. Now, if we look at 33 being divided by negative 4, it's definitely not going to go in there evenly. So, there's two answer choices that you could possibly see. And one of the answer choices will be, or could be, negative 33 over 4 if it cannot be simplified. Or you could see negative 8.25. That's your decimal form. Okay? Alright, so looking at what we just went over, we learned how to solve by combining like terms. If you have any questions preparing for class,